So MnTopo 2 has been rolled out. It's replaced the original MnTopo, and it's kind of a work in progress. As you can see, there are some holes, but we're getting close to filling in those holes with a seamless half-meter resolution data set for Minnesota. And as you can see, we've added a lot of bells and whistles and functions, utilities, tools, data layers that a user can use to explore these data touch these data, get familiar with these data from a web application. And then we'll also go into detail about how to actually download and access these data at larger scales or smaller scales for areas that you desire. So currently, as I mentioned, MnTopo, the original MnTopo has been decommissioned, and now you're being pointed to MnTopo 2. I noted that the seamless DEM is in the process of being rolled out. So there are a few holes that should be coming online later this summer, as well as you'll have access to metadata, things like hill shade, on-the-fly contours, flight swaths, and some reference data as well. But later this summer, you should expect the entire data collection to be, or most of the data to be visible on the MnTopo 2 front end. You'll have the authoritative 3D geomatics contours. They should be visible in the application as well as available for download. You'll have things like hydrographic position index, and further down the road, we will be rolling out things like DSM, building footprints, hydro break lines, cloud optimized point clouds, canopy height, etc. So MnTopo 2 is going to grow throughout the summer and into the future, and be ideally a one-stop shop for users to explore these data and get familiar with these data. So with this MnTopo 2, we realize we're using a lot of different data formats than the previous MnTopo. We're leveraging different technologies to serve these data. So we do have a few training videos as well as lots of great documentation, and I'll get into that once we demo the application. But there's a lot of information that users can access to kind of get familiar with these new technologies that are being deployed. And again, MnTopo 2 is kind of your access point to these data. We didn't want to build an actual software. Rather, we wanted to have a web application that allows users to kind of get familiar, understand the data, and then that being the jumping off point to actually accessing and downloading these data. So it's not, MnTopo 2 is not designed to be software, not for power users. We're assuming power users are going to grab the data they want and bring it into their local clients. So with that, I'll do let me stop sharing here for a second. And I'll bring up the MnTopo application. Okay, Megan, can you see my screen?
I can.
Awesome, thank you. So this is the new MnTopo 2 front end. So some things we've added. When you go there, you see a terrain color ramp of the seamless DEM. And like all web applications, you can use your mouse to zoom in and out. The URL has a dynamic location and level tag, so you can copy and paste. You can zoom into certain areas, copy and paste this link, share it with others, and they'll go directly to what you're looking at. We've got some zoom in and out toggle buttons should you not want to use your mouse. We have a zoom to extent function that allows you to get back to the entire state extent. Then we have some tools that you might be familiar with from the original MnTopo. So we have an elevation profile tool. So let's go to this river valley here. And if I click a couple spots, you can click more than one. We can make like a Big Dipper here. You'll see instantly a preview of 10 points along this line. And then once the data has been fetched, it will quickly populate 100 points. We fixed it to 100 points for any line that's drawn. And those are interpolated within an equal distance along that line. But yeah, you'll see this elevation profile that I just drew here. You can see the units in metric or imperial. You would have the access to download these data as a CSV, so you'll get lat long points. See, I can open up this CSV so you can see. If I bring this over here, you'll get the distant steps in meters and feet. You'll get elevation in meters and feet, and then you'll get a corresponding lat long. And then we also have a little marker tool, which users can click anywhere on the map, and they'll get the corresponding values for lat long, its native projection, UTM-15, as well as meters and feet. And then we also have a download tool, which is a little different from the original MnTopo. This is kind of leveraging some of the new technologies. So if we draw a shape here, you should see some text files that will point you towards the data. So here under the second generation data, you can download a text file here that will take you to some great spots for you to access the data. So you can access the image service, an Esri image service. You can access a virtual raster tile, which I'll explain what this is in the next slides. Metadata, access to a stack catalog, which Bill's going to go in depth into, as well as some good information on how to use these new jumping off points. You can also go directly to the stack browser, which Bill will get into subsequently. And then we've made it possible that you can get a download link for the original MnTopo data, which will look something like this. So on here, you'll get links to the actual raw data, the LAS file, as well as a geodatabase, which will have within a 1K by 1K tile all the seamless DEM, the 1 meter first generation DEM, as well as the derivative products. So things like contours, hill shade, and what have you. So also, we're also hitting the USGS National Map API, so it's actually not working at the moment. But you would also have access to first and second generation LAS data when their API is actually working. In terms of exploring the data, if you click on this layer tray, you can see we have a few base maps you can toggle between. Those are below what we're currently looking at. We have on-the-fly contours. So if I click on these, you'll see these dynamic contours, which is a canned Esri function that generates on-the-fly contours. We can change the color. Let's go with black here. And it gives you a dynamic index and intermediate contour legend here. But I want to specify that these are generated on the fly with Esri. There's no labels, and these are not the authoritative contours that we'll be rolling out later this summer. That we're using the process recognized by 3D Geomatics. So this is kind of a stopgap to allow users to kind of see contours while they're toggling around the map. However, these contours will be replaced later this summer with the authoritative 3D geomatics contours. We have some various color ramps of the DEM. Here's a grayscale. Here's an accessible color ramp. So this is user-friendly for folks that are colorblind or have some visual impairments. The color ramps, you can also toggle on the opacity as well as you can with the hill shade as well. You can kind of, so let's say you want to see roads as a reference, you can take these down a little and you can see some things like roads and cities and parks and stuff like that. So you can, and then when you get to the area you desire, you can turn it back up. We have access to flight swaths for the second generation data that are interactive. So you can click on them and it'll take you to a link to the metadata tied to that specific area. And then we have this layer here, which as I noted earlier, let's throw a DEM on, which indicates data you should be expecting. So areas in yellow, at the moment, these data are not available. As my understanding is that it's somewhat fluid. Maybe at some point down the road it could happen, but in the near term, these are not available. However, the areas in blue are forthcoming and should be online again later this summer with this Red River area as kind of the main priority to fill in that gap. So this second gen DEM, seamless DEM availability layer will be changing as more data comes online. Then we also have access to the first gen data. So here, this is the 1 meter first gen seamless DEM, and we can throw on the hill shade as well. So if users wanted to explore the older data, and the authoritative contours are also available. You have to zoom in a little to activate the layers. And then finally, we have a county layer. So if you wanted to get a little more context in terms of where you're at on the map, you can turn on a county layer. And a lot of these layers have dynamic legends that will appear or disappear based on which layers are on. We do have a search function. So if you wanted to go to White Bear Lake, you can navigate to that area using the location search. And we have a plethora of documentation here in the frequently asked questions, which gives you a lot more context, in-depth source information, how to use the map, explanation on what's going on in the background, as well as things like, this is where you can find video tutorials, as well as download instructions, download access. So in a nutshell, that is the new MnTopo 2 front end. And as we dive in deeper, I think a lot more of what's going on in the background will be more apparent. So with that, let me get back to the presentation. All right, let's figure out where we were. Okay, Megan, you can see the slide deck now?
Yep, we're on slide 6.
Awesome, thank you. So how are we serving hundreds of thousands of 1K by 1K seamless DEM tiles? Well, as with everything in life, data is migrated up into the cloud, which makes it more accessible for back-end users, front-end users, ETLs, et cetera. And one of the in that evolution, we've seen raster formats and vector formats kind of evolve to be optimized for living in a cloud. And so what we have in terms of data extensions to power these image services, to power these vector raster tiles are things we call COGs, and those are cloud optimized geotiffs. So it's a raster data format that leverages headers in the data to optimize what the user is seeing at different zoom extents. So it's just fetching what you need based on how far you're zoomed in or zoomed out, and then it will re-render on the fly to give you a better, more detailed picture without grabbing all the data at once. So my colleague Bill likes to use the analogy. It's kind of like Netflix. Netflix is using cloud technologies to serve thousands of videos and movies, shows, and it's optimized in the sense that you don't have to download the movie to get what you want. You can, pick a movie and zoom to a certain spot and see that instantly. It's think of it like that. That's how those cogs are working. And they have these things called overviews, which for a lot of you GIS users, you can kind of equate those to kind of like pyramids, is where they have kind of these cached views of the data that are called, whether you're zooming in or zooming out, and they're designed really for minimal data transfer. So they're super efficient in terms of grabbing those data and serving them. And then so when you have multiple cogs, you can deploy a VRT or a virtual raster tile, which is essentially, again, for context for GIS users, it's kind of like mosaicing all these cogs into one giant cog, but being very efficient about it and not having to create a mosaic, an actual file mosaic. It's simply a flat JSON that can kind of knows the order and the headers of those overviews to kind of render that giant mosaic on the fly very efficiently. And before we get into kind of why we did this, one of the key things to remember is don't download the data, access the data. And that's what my colleague Bill is going to get more in depth into and how we're leveraging Stack.
Yeah, thanks, Soren. Yeah, so the cloud optimized geotiffs that are powering this data are really big. They're like tens of gigabytes. So rather than downloading tens of gigabytes of data that you don't want or need, we're going to talk about how to access the data in a way that you can get just what you need and not what you don't. And so one of the ways that we're helping kind of smooth some of this workflow for users is by using what's called a spatiotemporal asset catalog, or a stack. And this stack is an open standard for describing geospatial data, particularly raster data, in a structured, searchable way that's using simple JSON. So this is a format that's meant to be widely interoperable. And it's used by USGS, ESA, NASA, Microsoft Planetary Computer, Google Earth Engine, and even by the state of Minnesota. And the way that Stack works is that it organizes data into a hierarchy. So there are things like catalogs, which are the root directory. It's kind of like a folder of things on a computer. And then within that catalog, there can be different collections. And collections are a GeoJSON feature collection of things that share common metadata. For instance, there are collections of the Landsat 8 imagery from USGS, or digital elevation model tiles for the state of Minnesota. And then within those collections are items, which are GeoJSON features that represent a single data set or a single collection event. For example, one satellite scene from Landsat or one cloud optimized GeoTIFF file. But also it has its metadata such as the bounding box, the date and time that was collected and published, potentially processed, what bands it has, and other relevant metadata. Which fields are there are a bit flexible. And then within each item, there can be assets, and those assets are just a URL for the actual data. And that asset can be attached either to the to an item, or it can be attached at a collection level. So one way to think about this is that Stack is kind of the new card catalog. It is a machine-readable format, GeoJSON, that has metadata in it. So it can be used by things like the Stack browser application, which we'll demonstrate in a minute, QGIS, ArcGIS Pro, other spatial programs such as T-Tyler. A lot of things, if they can work with GeoJSON, they can be made to work with Stack. And Stack can be served out in a variety of different ways. It can be either the OGC feature service, at which point you get a full-fledged API that you can interact with, and it's just like a normal feature service that you would use for other things. Or it can be a static JSON file, which is a little bit easier to get started with, but can be a little bit harder to manage once you have a larger catalog. The data can be stored anywhere you like, as long as it's accessible via a URL. So you can link to have things in your catalog that might be accessible from a third-party site. And what's cool about Stack is also that you can get consistent behavior across different catalogs. And what I mean by that is that the workflow that you develop that works with the MnGeo stack is the same workflow that you could use with, say, the Kentucky stack, or with one from a different provider like NASA or USGS. And so as you learn to work with these, it's consistent in how it works regardless of whose catalog you're using, and you aren't having to learn, oh, well, this is how the Minnesota topo data catalog works, and this is how another data catalog works. And so you're not having to learn a new portal every time. You can learn how the stack works, and you can just go with that. So next, I'd like to actually share a little bit of how to use the Stack browser. Different screen here. So this is the homepage of the Minnesota Geospatial Stack catalog. It has a brief description, And then there are a variety of these different collections that have different data in them. So for instance, we could take a look at the Minnesota 100-kilometer sections. So this is now one of those collections. And we can see a preview of a few of the items that are in this collection. It is paginated, so I think it's showing 10 or 12 results by default. We can get previews of those different items. And if we go actually look at one of those items, it tells us, one, that this is going to have a asset type of a cloud-optimized GeoTIFF. We can look in here. It can give us a preview of that data set on the map. It also has a thumbnail that it can show. And then it tells us some of the metadata about it, such as when this was published, the time of the data collection, the resolution, the bounding box, and additional things like that. It tells us that this cloud-optimized GeoTIFF is over 140 gigabytes. So again, you probably don't want to just download this data. So do not click the download link that's on here. But you can copy the URL and put that into a GIS client that knows how to work with cogs, and that will be an efficient way to access that data. There's also the link here to the metadata XML file, which you can either download or copy the URL and then see that statewide metadata. If you wanted to search for data, we can search for either collections or for items. You can specify a date range if you have a specific date range that you want it to match. You can also do this by setting a bounding box. Zoom in to Minnesota. So if we want to take a look at what data sets are available around St. Anthony Falls, we can click here to set our spatial extent. And we can just let that run. And it tells us that there are 4 different items across our collections that have data in that area. So one is this 2nd generation seamless Lidar DEM. This is the virtual raster. We have the Central Mississippi Work Unit Cloud Optimized GeoTIFF. We have a second one. And then there's this 100 kilometer by 100 kilometer tile as well. So that's a way that you can find the data sets of interest. And again, we could have, we can specify the collections if we wanted to limit things there. So that is the stack catalog. Now, back to the presentation. All right. So the workflow for GIS clients is a little bit different now with this new MnTopo data. So previously, you would go to the MnTopo application, you would select your project area, and you would click to download the data. Here we're going to streamline that and show you how you can actually go straight into your GIS client, load the data directly into your GIS client, and then you can use your GIS client to then clip to your area of interest. And in doing so, you're only viewing the data that you need in your map. You don't need to get any of the data that isn't a thing that you're asking for. And then if you want to do analysis or computation, you can clip right there in your GIS client to the area of interest or to the bounding box. It's important you want to clip to the bounding box, not to a complex shape, because it's so much faster for it to do the bounding box clip rather than a complex shape clip. And that's then equivalent to the download functionality. And it helps to keep the amount of transferred data as small as possible. So it speeds things up for you, and it makes things just smaller on your hard drive too. Okay, so with that, I'm gonna get ready to demo here what this workflow looks like in ArcGIS Pro. We're going to look at the Morton Nice Scientific and Natural Area. There is a bug that prevents access to cloud-optimized GeoTIFFs that are in publicly available Azure storage, which is where our COGs are stored. That affects ArcGIS Pro 3.5 and below. So at Pro 3.5 and below, you will need to use the image service to access this data. However, once you migrate onto Pro 3.6 or above, you can use the VRT and COG workflow that I'll demonstrate here. I'll also point out with this that if you were trying to use COGs or stacks that are hosted by other organizations, that those may work in lower versions of Pro if they're not stored as a publicly accessible Azure blob storage. So if they host it in AWS, you should be able to use this today on those other data sets. So here we are in ArcGIS Pro. So what we are going to do is we will start by adding a connection. We'll add a stack connection, or we will create a new stack connection. Call this MnGeo stack. Put in the address of our stack catalog. We don't have authentication on it. Everything else is default, so we can say OK. Here, you can double click our stack item in the data catalog. That will then bring us to exploring the stack. So the first place to start is probably this Minnesota virtual raster tile. So we will start with that. And we will just view all the results without any further filtering. And here it gives us a little bit of information about that. It shows us this thumbnail. We can have it display the footprint on an active map. We can take a look at the properties of it. It can show us some of that metadata. So it tells us that we have half-meter resolution data, when it was published, lots of other things like that. Then it also has the item assets, tells us that we have this VRT, and it gives us a path to that. So if we wanted to, we could copy this path and add it via the open from URL tool. But because this is a VRT and Pro knows how to work with that, from a stack, we can actually just add the item to a new map. And this will then think about building a new map for us, and it will add the VRT to that map. And we should be good to go in a few seconds with all of that. Apparently it wanted some coffee still this morning.
Loading bars on live demos is very good content.
Yeah.
I'm sure I'll go through the same.
Making some progress. Okay, we see our soda shapes open up, so let's zoom into that. And I'm going to turn this off for a moment so that I can try to find Morton. Here we are. Okay, so here we are in Morton, so we can turn our layer back on. And we can see that we probably want to change some symbology on that. I probably should need it. Can you see the symbology screen, or is that not shared properly, Soren?
Yeah, I can see it.
Okay. So we are going to, stretch is fine. The color scheme will give this appropriate color scheme. Here's one that'll work. And for the statistics, rather than using the data set, we'll use dynamic range. So this will rescale to whatever our view extent is. That's good for now. So we can see the data here for this area. And now we can go to flip raster. Specify our input raster. And the extent, let's zoom in just a little bit more. We will use the display extent for that. And we can run this. And now it's actually downloading just the data that it needs to create this clipped raster for us. So if I turn off the other layer, we can zoom out a little bit, see this raster. This is now clipped to just the extent that I asked for. And we can again update the symbology here. Give it a different color scheme so we can tell it apart. And again, we can use either the data set or the dynamic range coloring for this. And as we zoom in, it will again give us the different coloration as we zoom around. Again, this is just a demo, so we probably would not make these same choices for something important. Another thing that we might want to do is to build some contours. So if you have access to the 3D Analyst or Spatial Analyst tools in ArcGIS Pro, you can then use this input raster of the seamless clip. The contour interval, we could make something like 0.5 if we want a 0.5 meter vertical contour interval. And we can just run that. And now we have our contours available for just our project area at the size that we want. And the cool thing about all of this is we were able to do this data exploration and extraction and everything right here within within ArcGIS Pro. So we didn't have to go out to a website, click around on a website, learn that front end. We could just do all of the operations that we needed to do for our entire workflow right here in the GIS client. So with that, I'm going to turn things back to Soren, who will demo a little bit how to work with QGIS.
Thank you, Bill. So I'm going to do a similar exercise as to Bill, using the open source equivalent to Esri Arc Pro, QGIS. Bill, can you see my screen?
Yep.
Thanks. And so I'm just going to run through a similar exercise on accessing the data rather than downloading an entire giant cog. And so you can see we're in Minnesota, and I want to set up a stack connection. By default, in the browser tray, QGIS has a stack browser here. So if I want to establish a new connection, I go to New Stack Connection, and then I will grab the stack catalog, which I just posted in the chat. So you would throw that in the URL here, and you can give it some name that you'll remember. I'll call it Minnesota Stack. Click OK, and then all of a sudden it appears. And now with this arrow here, you can open up the stack catalog and see all the items, or I'm sorry, collections and their subsequent items. QGIS is kind of wonky as an open source product as it's currently being built out, made better on the fly. So with things like a cog, you can easily drag and drop into your layer tray, and the cog will appear. However, with virtual raster tiles, like the one we've stitched together for the entire state, they don't give you that access. So but you can still access it. You simply have to just right click on it, go to the details, and scroll down to the VRT. And you can grab this VRT link from a variety of places. It's in the download tool, it's in the stack catalog. But here, this is the quick and dirty, just grab it from the details. And you can see there's also metadata associated with this. So if I copy this link and go to add raster. Oh, it's already
Just a
in there.
warning, you missed the H in there, so careful
Oh,
when you
okay.
paste.
All right. Well, it cached my trial here. So I have it in there. You want to save it as HTTP, protocol HTTP. Add that. And we'll see if I can beat Bill's timing for loading of the. Get rid of this here. There we go. I think QGIS beat it. So, and then now we have the seamless DEM for the state of Minnesota as it appears now. And again, these gaps will be filled in ideally pretty soon, later this summer into June. But so you can explore the seamless DEM. And again, I haven't downloaded anything. I'm accessing the data. So it's just calling it the VRT from our cloud storage. And let's say I want to, well, let's zoom into an area. Let's go to the driftless area. There's some nice topography there. Find this nice river valley. So I want to do something similar to what Bill did. So let's say this is my area of interest. I want to know more about this area. And I don't want to download the entire state. So if I go to processing here, bring up the toolbox, and let's go to clip and clip raster by extent. So I'm pointing to the seamless DEM and I want to clip it by my current view extent here. This is all the data I want, and this will save locally rather than downloading the entire state. If I run that, so within a few seconds here, we'll have my data. If I zoom out, so that's all the data I care about. And I just had to grab that rather than download the entire state. And similar to Bill, let's mess around with the symbology here. We got a single band. Make this dynamic rendering statistics. Apply that, and you can see now we have this cool raster without downloading the entire state for just the area I want. And let's run some contours on it. We go to the contour tool here. I'm using the clipped extent that I just created, and let's do an interval of 1. Run that. Change the symbology here. Make those darker. So now, within seconds, I grabbed just the area I needed without downloading the entire state, ran a function on it, contours, slope, whatever you want to bake into your processes. And you have all these data locally, and they're digestible, small bytes for what you need. So I'll stop there and go back to the presentation. All right. Oops. Sorry, we'll scroll to where we left off. Can you see my screen, Bill?
Yep. Right there.
Okay. And so I've already fielded a couple questions from one of the experts that the 3D geomatics team, folks at DNR, the number one thing folks want are contours. They're very useful for a variety of reasons. And we totally understand creating those contours on half meter resolution data for the entire state it's a big task, and we're working at it, and we appreciate everybody's patience. As we noted in the MnTopo 2 front end, we're displaying on the fly contours for a little reference, but those are not the 3D geomatics authoritative contours. Those, however, are forthcoming. And ideally, we're shooting for some time in the middle of summer to have those rolled out and deployed into the MnTopo front end. And we had another question regarding kind of how can you get to those contours? Our intention is to have a vector tile service that will render those contours and make labels for the front end so users can interact with them and play with them. And then we will also integrate into our download tool a way for users to draw whatever area of interest they want, and then they will have access to the actual contour data for download. So appreciate the patience while we get those rolled out. And then we have this slide here. I know other folks have asked what's the link for the browser, what's the link for the stack catalog, front end, etc., image service. So this will be made public, so you'll have a reference on where to find all these things. And then finally, to summarize, you know, this was a big challenge to get all this really awesome, useful data and make it public, make it accessible, make it downloadable, make it visual. And it required us at MnGeo to kind of pivot and think about our infrastructure, how everything's being deployed to the cloud, and how we can optimize delivery of those services. So to summarize, you know, to do that, we're using cogs. We're organizing the data in a stack. We're deploying new technologies like the stack so users can throw giant data sets into their local clients like QGIS or ArcPro, access just the areas they want, and then download those small chunks rather than downloading tens to 20 or hundreds of gigs of data. And this workflow is evolving into many other large data repositories, as you know, as Bill noted, NASA, a lot of satellite companies, a lot of other states are leveraging Stack to make data accessible, large data that lives on a cloud. So getting familiar with this will help in your data analysis, your ETLs, your processing to kind of learn how to get at these huge pools of data, but just grab the couple drops that you need. And this is Bill's favorite slide here. So if you remember one thing, don't click the download link on the second generation data. I fielded another question in the chat that I will take the blame on creating this confusion. We do have the option to download, and in the stack there's a download button. You can download it, but we're trying to guide users to access and download what they need in their local clients versus downloading, big chunks of the state of Minnesota. The first generation data still exists in FTP form or view or from the download tool, and those ideally, as time goes on, will also be integrated into Stack as if time permits. However, this confusion on download and access is warranted, and I take the blame. But I think learning on how to access data versus download second gen data will help you in your workflows and keep your storage on your local machines down. But you do still have the option to download. But we'd advise if you access it, get your small chunk and go from there. So we covered a ton of stuff, and I know this can be confusing, these long demos with all these technical terms. So I think now is a great time to field some questions and get some responses from the folks on the call. I don't know, Megan, do you want to manage or help us field some of these? I'm seeing some I have answered.
Soren, I'd like to interject, and I think that there are a number of them that can be explained fairly quickly and that kind of got to the same thing. So there were a lot of questions about, hey, where can I find the link to X, Y, or Z?
Mm-hmm.
And let me show you how to do that, because the links that we've been sharing here are actually in the FAQ page that's on that on the MnTopo front end site. They may be a little bit scattered through where they are, but they're going to sit within certain themes. So for things like the data access, we have here links to how to get to things, including here's the stack catalog, the machine readable version. If you are a human, you don't want to click on this link and go there. It's going to be a bunch of JSON that isn't super interesting. The stack browser is linked here. The link for the virtual raster itself is here. Additional data on the second generation Lidar collection has its own page that's linked here. So all the links that we're mentioning are under appropriate headings here in the FAQ page of the MnTopo web application. But we'll also be sharing this presentation, which has the links kind of conveniently on one slide for you as well.
Bill, related to that, will the link to this training recording be added to the MnTopo 2 application?
Yeah, we should be able to do that pretty easily.
Okay.
Yep.
Okay.
Well, how about we scroll through some of these unanswered questions and Bill and I can try to answer. Okay. One says, sorry I joined late. I may have missed this. Are there instructions for linking stack catalog in ArcPro? Oh, yes, there are. So as Bill noted, the FAQ, again, is your one-stop resource. There's video tutorials. This presentation will be recorded and disseminated on the MnTopo 2 FAQ. So yeah, you will have a guide to guide you through it. Next question, what versions of ArcGIS Pro will Stack work with? I have ArcGIS 3.55 and it can connect, but it doesn't allow data to be added to the map. Bill, you want to respond to that one?
Yeah, that's due to some bugs in ArcGIS Pro. That's a complicated answer. The stack functionality in general, I think came in somewhere around Pro 3.3, but it may have been a couple versions. It may have been a version or two on either side of that. However, there is a bug specific to cogs stored in Azure that additionally do not require a user to be logged in to access. So that can be just anonymously accessed. Those particular cogs cannot be loaded in Pro 3.5 and below. So if you were to try, accessing the state of Kentucky's Lidar and imagery data via their stack, you could do that at Pro 3.5 and maybe even a version or two below that. So the stack itself is working, but there are then some other bugs that you can run into in Pro 3.5 and below that affect specifically the way that we have hosted our data. And those are fixed at Pro 3.6. It's not an issue in QGIS. So that those fixes will be coming. Another thing sort of related to that I guess we didn't call out specifically, but we should, is that stacks and cogs are relatively new technology for things like GIS clients and particularly for CAD clients. And so the specifics of how these user interfaces work within the desktop clients may change in the future. In fact, it probably will change in the future because it's under a lot of active development as more people start using it and adding functionality. But we are really excited about bringing this new technology out for you with MnTopo 2 because we think that this is going to be, in the long run, a way to make things a lot easier, and it will make things more consistent, especially once we get over some of these initial hurdles of getting more software supporting some of these newer formats. But I think in all cases, it's going to be coming soon. I have seen a number of Autodesk forum posts saying, "Hey, we really want this, cog support in AutoCAD," and it sounds like that is a feature that they're probably working on. So I think to some extent we're ahead of the of where some of the software is, but I think some of these growing pains will be going away soon, and things will be working pretty smoothly in a little bit.
To piggyback on Bill's great explanation, if you have a version of ArcPro below 3.6, you do also have the option to use the second gen seamless image service. So you could also pull that in if you wanted to play with the data in ArcPro if your version of ArcPro doesn't work with our current stack. All right, let's go further down. Will you have this available to download through FTP site for us that want to download the large areas? Not in an FTP site, but the stack is more or less built functioning like an FTP site. So if you go to the stack and you really want to download those huge chunks of data, you can, but we'd advise if you access your certain area, it'd be more efficient, but I guess that's up to you. How are stack file share permissions configured? Do you understand that one, Bill? I think it's all public, so I don't think there are permissions regarding the data or.
Yeah, at present, all of our stack and all of our the data that's available on our stack does not require authentication. But there are ways to have both an authenticated stack catalog or to link to authentication required data sets. We just haven't done that yet.
Thanks. The next question, can stack files be stored in Azure Portal? So things like the stack catalog or assets within the catalog, yes, you can. That's we have all our cogs in Azure. Next question, how can this data be accessed in CAD? I'm not a CAD user, so I won't begin to answer. Bill, do you have any insight?
I don't have. I guess we do have, and I guess we didn't call this out enough. We do have an Esri image service, which is available with this data, which it's my understanding that that image service would be available for CAD users. As with many of the other things mentioned here, that is available for publicly, so it's not a restricted space. So you should be able to access things through the Esri image service if you're using Pro 3.5 or below, or in CAD clients.
Thanks. The next question I see is there a way to freeze the color ramp? I'm not sure I understand the
There's
question.
Yeah, so in the front end, there is not currently a way to freeze the color ramp, but we can take that under advisement as a potential future enhancement.
Okay, I think we've gotten through. Pardon my fumbling. I'm trying to learn on the fly how to navigate these questions. Can you demo the image service? Would you be up for that, Bill, since you have a better connection? Pulling that into Arc Pro?
Yeah, I think I should be able to do that. Yes, need to find the image service link. Fortunately, it's on my FAQ page. Where's the link for it?
So the image service, if you use the download tool, it'll appear in the text file for
Okay.
every area, any area of interest that you draw if you need future reference.
Okay. Download link. There's the image service. There we go. Okay, we will add data from path. We'll paste the path in there. Add that data. Did that fail?
While Bill's troubleshooting that, I can go through answering some more questions. What's the link to add to QGIS so I can access the stack catalog? So if you have QGIS downloaded, there's in the browser pane on the left, usually there's a stack call out or item, and you can right click on that, and I can show you here. Go back to. So if you have QGIS loaded here, you right click on there and say new stack connection, and you would put the stack there, name it what you'd like to name it, and then it would appear under. So you can see I've added a stack catalog for Ukraine, and they have some, I think these are agricultural fields. But as Bill noted, there's a huge catalog of stack catalogs out there. Next question. It looks like I only have Arc Pro 3.55. Any ideas when version 3.6 would be available, where the bug fix is made to access the stack? 3.6 is available now. I'm not sure at your employer or agency if they have the capacity to upgrade, but once you get to 3.6, it is working. And as Bill noted, stack catalogs, ours essentially doesn't work because of a bug with Esri and Azure Cloud, but in older versions of below 3.6, where stack users are leveraging AWS or Google for cloud services, those will work. Your download button allows you to draw an area of interest, but it appears to give the same links. Yeah, what is its purpose? I think that's kind of to condition folks, at least for the second gen data, to go to the stack and access the data rather than download. For first gen data, the links will be different when you change your region or go to a new geography. As derivative products roll out, so things like contours, those will have unique links based on where you're at on the map. But for the moment, the link is redundant for second gen data because we're trying to push it to the stack catalog to access or download those data.
Okay, I'm ready now with my with the demo. So when we are in row, to add the imagery service data, we can add data from the path. We will paste in the path to that image service. Just say add. Adds it. We'll turn off my contours, my other stuff. Again, we can change the symbology for it. To use the dynamic for a color scheme. That was not what I wanted. So we can use a color scheme on that. And now we have our the Esri imagery service. And so this would be a way to grab that data if you're working in Pro 3.5 or below. And again, this is then what you can use to do any analysis that you would have on these data. So that's what I've got for that.
Thank you, Bill. Okay, let's get back to the questions. What about MnSight, the mobile hillshade viewer app? Is there an update to that, or does MnTopo 2 through a web browser replace that? Unfortunately, I'm unfamiliar with MnSight. Are you familiar with that, Bill?
I'm not familiar with MnSight, but there is, the MnTopo 2 does have that hillshade viewer, which is showing hillshades for the areas where we have that DEM data. That's available through a browser. The app does work on mobile, so you can get that via mobile as well.
Thank you, Bill. Next question, is there any plan to have PLSS layer in MnTopo 2 that can be turned on and off? Township sections, etc. That's a good question. I think there are a variety of reference data, other vector data that are planned to be integrated. I'm not sure PLSS data is on that list, but we can definitely follow up with that. One option you have is to load the specific PLSS data you're interested in your viewer and bring in the VRT or the image service, and you can interact with it there. But I appreciate the call out. We'll make note of that in terms of how the app evolves and what are the kind of the most requested reference layers. I should note PLSS data can get pretty voluminous. There's a lot of vertices in some of those parcel data sets, but things like townships and sections, I think, could probably work. Okay, another question. We need feet, not meters. Can we convert on the fly from the stack? That's a great question. Bill, do you know, the stack is going to serve the data natively, so you're going to get it in UTM in meters. So you could go to your area, clip out your spot, and reproject it to feet rather than meters. Or Bill, do you have any guidance?
Yep. Or you multiply by, what is it,
Oh,
3.028 or something.
Do the math.
Yeah, yeah, so it won't have the, once you pull it into your GIS client, it's going to have you, there should be a way to then tell it to just multiply that raster value by some constant factor.
Great. Next question, is there a way to use the second generation data for analysis in ArcGIS Pro in versions 3.5 or less? Yeah, I guess as Bill just pointed out. You want to go, Bill?
Yep, that's to use the image service. Okay, yeah, and Brooke just asked a good question here. So what's the difference between the image service and the stack? Is it just speed? Well, the stack itself is just a data catalog. So the stack is nothing but a collection of links to where you can find data. But the stack has in particular links to these cloud optimized geotiffs, or the virtual raster, which is itself a sort of collection of these cloud optimized geotiffs. So the Esri image service is providing sort of a translation between your GIS client and the cog. So the Esri image service can read the cog. Your client has had, here's the area that I'm showing on the screen. Please give me the appropriate the appropriate tile showing the elevation data here. And the image service then grabs the data from the cog, renders that color scale onto that data, and then sends it back to your client. Whereas using the cogs, which you can get directly from the stack or from the VRT, those just pull the data directly from the cog, and then all of those rendering steps are performed locally on your machine rather than on the server.
Thanks, Bill. Next question. In MnTopo 2, when you do the elevation data and coordinates tool, can you easily copy and paste the coordinates for pasting in another place, say Google Maps? The data on the app is projected in Web Mercator. So I believe Google Maps uses Web Mercator as well. So the coordinates in the let long tag in the URL should take you to the same place. Or I guess in the pop-up, yeah, you could use the coordinates rather than the UTMs, obviously. Yeah. Will the authoritative contours be in half meter or half foot? Our intention is to deliver the contours at 1 foot interval.
Yeah, and I apologize for the confusion there. In my quick demo, I was demonstrating how to make a half meter vertical contour. So that was my mistake. Sorry about that. But yeah, we'll be putting out 1 foot contours.
Question on LiDAR contour accuracy. How is the LiDAR able to establish an accurate contour if there is a 12-foot deep mat of dense grass? That's a great question. I'm not a LiDAR expert. I don't know any 3D geo folks on the call. I don't know, Bill. I think, yeah, that's when you have high resolution and you have kind of things like grass that can move with the wind or be matted down, I think that might may or may not impact. I don't know.
I see Mike has his hand raised. I will allow your mic. Mike. I think you can come off mute now, if you would like. Or if anyone else from the 3D Geomatics committee would like to speak to that, you can raise your hand.
Yeah, I was just going to suggest Rick Moore or Sean Vaughn. And I believe I saw Rick on here, and I'm assuming Sean will be on too. Yeah, Rick's on. Rick, do you want to raise your hand?
I've just allowed Rick to come off mute if you'd like to do that, Rick. don't see Sean. Adam, let me get to you 1 second. Okay, Adam, your mic is enabled.
Morning, everybody. So every USGS LiDAR project has established accuracy, which is different from a hard surface versus not vegetated surfaces. So your project would have had independent LiDAR control that tests it in the area that your project area is flown, which is multi-county project areas. So if you have a QL1 project area, which is the majority of Minnesota, your hard surface accuracy is somewhere around 0.3 feet, since we're talking about feet here. It's about 3 times that for your vegetated surfaces. Tall grass, wetlands, typically in testing the data is usually the most suspect. That's going to fall somewhere around, I think it's like 19.5 centimeters is what the vertical accuracy spec for USGS data is. Usually these projects are tested and flown to beat that specification. So it is going to be different accuracy standards in a hard surface or a mowed lawn inside a town versus your wildland areas. It's going to vary project by project area a little bit, but there should be vertical accuracy reports out there that you could reference. I hope that answers your question. Obviously, the contours are a child of your DEM. So your DEM should be slightly more accurate than your contours, but I think that's the best answer that anyone could give you. Or Sean Vaughn, he might correct me or agree with me. You never know.
Can we unmute Sean for a follow? Oh, there he goes. Okay.
Yeah, sorry, I didn't. I think I just got access. All right. Everything Adam said is correct. And what Adam is bringing up is the recognition that an aircraft passing overhead is going to send laser pulses into vegetation and to hard surfaces. Those pulses and the accuracy of that data is evaluated differently, as Adam said. There's a complex thing that happens when LiDAR is collected, in that these are points, 3D points, that then have to be classified. It's a bit of a black box as to how vendors classify the points. That there is not USGS or ASPERS-based specifications on the point cloud classification. That's an important part to understand and take away, that there can be variability in what a point represents when it's very close to the ground. Is it a blade of grass from a full stalk of a forb growing? Is it mowed grass like Adam mentioned, or is it a hard surface? When you have these very, very tight tolerances that we see in modern day quality level 1 data, as we described, or Adam described, we can also see variability in the classification. So if the question that I understand was, what do you do when there's when the vegetation is very dense? Well, we try to address that by collecting quality level 1 data, which means 8 points per square meter or greater, with the hope that we can penetrate these dense mats. If we think about the first generation of our LiDAR data, very dense mats like cattails around a wetland, for example, did not get penetration because we only had about 0.7 points per square meter, approximately 2 points per individual, or 1 point per, that would be 1 point per 2 square meters. All right, so back on track. What this means then is, this is complex, this is a difficult thing to answer, but you could have more points, more pulses going to the ground, get some ground points. That helps the vendor's algorithm then more properly classify the points. All of that said, When this then gets carried over into the development of contours, we can only operate with the DEM that was created from that product. We have to trust in that we got a lot of points to the ground. We have to trust that the vendor's algorithm properly classified the points, separated bare earth from the vegetative mat, and from that, then, as Adam described, we create a DEM. Now, the DEM has to also meet the evaluation criteria as do the same as the elevation point cloud. We are operating in the state of Minnesota with USGS 3 depth certified data. The DEM is certified, as is the point cloud, to meet the criteria for quality level 1, 5 centimeters or greater in the vertical. Much of our data comes out and tests and evaluates at, as Adam said, there are evaluation reports, the accuracy report. Most of our data tests below the minimum threshold that I just described, and a lot of it to transfer into inches is somewhere within that 1 to 3 inch in the vertical accuracy for a lot of the data. That's phenomenal accuracy. That does not mean that every single point in that point cloud or every single grid cell in that point cloud represents that. It is on the test points only, the control. Those are on the ground surveyed control. So what you have is when you have survey control, and the survey control has to meet a certain accuracy as well, usually for 2 times greater than RMSEZ. So what that means then is you have an elevation point in the point clouds evaluated, you have a grid cell that's evaluated, but it's not for every single point. I'm going to stop there because I sense that this can get really complicated, but the question, go back to the question, was contour development. The contours have to meet a certain criteria, or at least they cannot be created less than 1 foot from a 1/2 meter USGS quality level 1 digital elevation model. I'm pausing because I'm trying to think if I answered everything that could be interpreted from all of that. But that's a good question, but it's a very complex answer. And I'm gonna stop there.
Thank you, Sean. Thank you, Adam. Appreciate the explanation. All right, I guess we can jump back into some of these questions. All right, I've filtered them now to get the most upvotes, so maybe we'll get to more popular questions. Sorry I joined late and may have missed this. Are the instructions for linking the stat catalog to ArcPro and loading the data available somewhere? I will not memorize the URL. Yes. In the FAQ page on MnTopo 2, there are instructions as well as videos. Rick, it's important to set your coordinate system in ArcGIS Pro and within your map. The coordinate system for the second generation since DEM data is NAD83 UTM zone 15 and NAV D88. It is important if you are clipping the data using the tools described so your output remains in the same coordinate system. Yeah, that's a good call out, Rick. The data stays in its native resolution, so when you're bringing it in, you're clipping it, you'll want to be in that coordinate system. When generating elevations and downloading CSV files, is there an option to get UTM coordinates rather than lat longs? At the moment, we're just providing lat longs, but I can flag that as a future enhancement. It would be easy to throw the corresponding UTM coords as well. Thank you. What is the difference between image service and stack? Just speed? Bill, you want to field that one?
We've already addressed that one.
Okay. Watch the recording again and Bill will. Should we use the regional work unit catalogs or the statewide VRT catalog? That's a good question. I guess the statewide VRT is going to be the seamless blended data. And it's my understanding that the work units are unblended. So I guess it's kind of contingent on whether you're entirely within a work unit or if you have to bring multiple work units. There might be some edge effects due to different flights. Hopefully I'm capturing that correctly. So if you want blended data, use the seamless statewide VRT. Is the image service URL listed somewhere? Yes, we'll respond to that with the URL. Is there a way to freeze the color map? We answered that. How are individuals who don't have access to ArcGIS Pro or QGIS supposed to access the data? Well, I guess if you're into data processing and you know how to use Python, you can hit the Stack API with Python. You can go to the Stack browser and explore the browser there and download data. But if you don't have access to a GIS client, doing analysis may be hard, or other open source tools. Bill, any thoughts?
I think that, again, that might get into, if you're using that, for instance, with a CAD client, you might be looking at using the image service to be able to get access to that data via the image service. But if those answers don't fit your use case, by all means, please be in touch with us, and we can. We'd love to learn more about what use case you have and how we can help support that.
Thanks, Bill. When you get the opportunity to refresh this, I think we answered that. Answered the Lidar question. If you add this as an ArcGIS server connection and then cancel when it asks for ArcGIS credentials, it adds an image server and you have more options to add as a path. Okay, maybe that's more of a statement. Where the areas covering tribal lands flown for LiDAR and not available, or were these not flown during data collects? I don't know, Sean or Rick, do you want to field that one? I believe some of the areas were flown, but I'm not entirely sure.
Which question are you on?
Were the areas covering tribal lands flown for LiDAR and not available, or were the areas not flown during the collects?
It's complicated. So for much of the tribal lands, the area was flown by the USGS prime vendor under contract with the USGS, an agreement that the data is controlled by the tribal nation. There is not an agreement in place for us, the state of Minnesota, for all of the tribal lands covered to be made publicly available. The Grand Portage tribal nation worked with that vendor directly. They own and control their own data for that very northeastern corner of the state, and the USGS does not. I hope that answers it sufficiently, and I'll summarize by saying that where you see the gaps in the DEM today, over the tribal lands, that's where they will remain until agreements are made for the data to become publicly available. As of right now, there are gaps in the data.
Thank you, Sean. Okay, MnTopo became an issue when the Lidar flight reference became very outdated. Will MnTopo 2 be updated with new Lidar as collected? Really, guys, you put a lot of work into this, so thank you. Oh, thanks. Yes, there's a lot of moving pieces, and folks are working hard to fill in those gaps, and that the data is collected. It's the seamless blending process and then integration into our workflows to deliver these data to the public. So it's in motion, and again, we're shooting for this summer to fill in those gaps. In regards to the question, in regards to the earlier question regarding copying the coordinates, just looking for a quick way to copy the coordinates without having to note them or retype them in another application. Is there a way to copy and paste them? Or elevation?
We'll take a look at that. Yeah, we're able to reproduce that issue, and we'll take a look at that and see about getting that fixed or enhanced as we have time and priorities to work on that. So thanks, Joel, for the suggestion.
Yeah, if you're using the tool and you turn it off, it'll allow you. I'm assuming if you like the marker tool, if you have it on after you've marked a spot, you can't copy what's in the pop-up. But if you turn the tool off, then you can copy what's in the pop-up, if that's what they were intending. Well, I think that's the last of our questions. I appreciate all the interaction, and
yeah,
I also appreciate the Lidar experts coming on to. Bill, you have something to say? Go ahead.
Yeah, I thought I'd just kind of follow up a little bit on Sarah's question about, new Lidar data getting collected and how that might change going forward. And that reminded me that, the stack catalog is new to us, but we are looking toward adding more data to that stack catalog. And so that could in the future be, a new round of Lidar data collection. But we're also looking at putting some of our imagery, our aerial imagery data sets into cogs and putting them into the stack. We would potentially set up a image service or a WMS kind of server so that could read the cogs and provide ongoing WMS services. But we are looking at adding additional data sets, particularly imagery, to the data that are available today in the stack catalog. So that's going to be one place to look for new data as it comes out.
Great. Well, I suppose if they're, yeah, go ahead, Megan.
Yeah, I was just going to invite anyone who has remaining questions to raise their hand if they would like to come off of mute if you had a problem with the Q&A at all, or if it was too complicated for the Q&A. William, I see you have your hand up. Let me get to you. Okay, I have enabled your mic if you would like to come off mute.
Hi, Bill Hockla, St. Louis County Land and Minerals Department. St. Louis County has been a partner, funding partner for the LIDAR data. And we are going to need the contours to be able to download. Working through a web service or anything like similar to that doesn't work for our needs. So we're going to need the ability of either getting you a hard drive or to an FTP site to be able to download this. We can currently like do the stuff of in a map session process, you know, a small area or whatever, but that's not our workflows. It's not what's needed. So we're going to have that ability. That was one of the promise derivatives of being a partner in a funding partner in this. So so that, and the other thing too, St. Louis County has for internal purposes only. We've partnered with Fond du Lac Band, so we have access to the raw LAS files. But I could not find documentation how the contours were processed in the original, and would need to know, because I believe you guys don't have access to that. So we're gonna have to do this internally on how to process the contours ourselves. So any help with that would be much appreciated. So yeah, that was my main comments there.
Yeah, so the contour data set as it becomes available will be available in downloadable form. Again, for most users, we are going to recommend that you use the sort of cloud optimized workflows, but as you mentioned, your workflow is not that. So yes, there will be downloads available for that. And then the I believe the 3D Geomatics team is going to be publishing their workflow for how they are building the contours. So I expect that that's going to be forthcoming. So stay tuned. It's coming.
Thank you.
Other questions? Well, based on the crickets, I think we can conclude this session. Appreciate all the feedback, the questions, explanations, and your patience with us rolling out these applications and services and data sets. And again, this will be made public, so if you need reference to all these acronyms and new terms we've been talking about, you should ideally be able to reference that. And the FAQ page on the MnTopo 2 application has got a lot of good references as well. So I guess from there, I don't know, Megan, is there we have a closing goodbye?
Yeah, I just wanted to share that we will announce when this recording is available through MnGeo's public newsletter. I had put that in response to a question that came in earlier related to that. And we will have links to the slides and maybe even an FAQ document. We'll see if we can get a resource like that available alongside that YouTube link for the recording. With that, I guess we can end early and everyone can have 5 more minutes for lunch.
Thank you
So much.
Thank you.